The term drainage is related to river. Rivers are the major geomorphic agent and operate fluvial process and are responsible for the formation of variety of landforms. The river takes origin, develops and flows in a particular direction due to some controlling factors. It is necessary to understand what are these controlling factors in the development of a particular drainage system. The main river along with its tributaries forms the drainage pattern. The drainage pattern differs from one place to another. The question here is why the river network or the pattern differs from one region to another. Here we are trying to resolve this observation with few objectives set forth as: 1. To understand the role of geological structure of an area in the evolution of drainage pattern and its type. Secondly, to know about different types of drainage pattern and their formation. A drainage system refers to the origin and development of streams through the time. The origin and subsequent evolution of any drainage system in a region are determined and controlled by two main factors. One, nature of initial surface and the slope, and second, geological structure like folds, faults, fracture, joints, dips, strikes of the rock beds and type of rocks. Drainage systems are divided into two broad categories on the basis of adjustment of the streams to the initial surface and geological structure as: 1. Sequent or consequent streams. Consequent streams are the streams that follow the regional slope as well as adjusted to the geological structure of the area. Insequent or inconsequent stream. Inconsequent streams are which do not follow the regional slope and are not adjusted to the geological structure. Depending on the geological structure and the slope, the stream flow in different direction. On the basis of flow as well as the direction of the slope, the sequent streams may be classified into 1. Consequent, 2. Subsequent, 3. Obsequent and 4. Resequent. Consequent streams. A stream in which the direction of flow is controlled or dependent upon the original slope of the land is known as consequent stream. Consequent streams are the first streams to be originated in a particular region. These streams have their courses in accordance with the initial slope of the land surface. In other words, consequent streams follow the regional slope. The longest stream of the whole system of consequent streams is called as master consequent. Subsequent streams. The streams that originated after the master consequent stream following the axis of anticlines or the ridges and the strikes or beds are called as subsequent stream. It is a stream that has developed along the regional fault or joint pattern at right angles to the drainage, which is consequent upon the slope of the land. The subsequent streams joins the master consequent at almost right angles. All the first generation tributaries to the consequent streams are subsequent in the sense that they arise subsequently to the establishment of the consequent streams. Generally, subsequent streams refers to the streams transverse to the master consequence. Song River, a tributary of Ganga River in Dehradun Valley, is an example of subsequent stream. Obsequent streams. The stream flowing in opposite direction to the master consequence are called as obsequent streams. For example, the Mahabharata range of the lesser Himalayas has several streams in the northern slopes. These northward flowing streams join the subsequent streams. 𝗧𝗏 which runs west to east as subsequent streams flow in opposite direction of the master consequence like river Ganga. Resequent streams. The tributary streams following the direction of the master consequence are called as resequent streams. Resequent streams are originated at much later date in comparison to the master consequent stream. Since they are of recent origin and hence they are called as resequent, they developed in response to new base level. The resequent streams are originated during the initiation of second cycle of erosion in a folded structure. The gradual denudation of the fold mountains during the first cycle of erosion results into inversion of relief. With the passage of time, wherein the anticline regions and synclinal valleys are converted into anticlinal valleys and synclinal ridges, respectively. Thus, the streams developed in the synclinal portion becomes the resequent. The stream which do not follow the regional slopes and geological structures are called as insequent or inconsequent streams. There are two types of inconsequent drainage. One, antecedent drainage system, and two, superimposed drainage system. Antecedent drainage system. Antecedent streams are those which are originated prior to the upliftment of the land surface. In other words, antecedent streams antedate the upliftment of the upland or mountains across which they have maintained their present courses through continuous downcutting of their valleys. Even though upliftment has taken place, the pre-existing rivers does not divert their courses, and the river maintains the previous course through downcutting its valley at the rate equivalent to the rate of upliftment of the area. Such rivers are called as antecedent rivers. When the rate of valley deepening is equal to the rate of upliftment, they will be able to maintain their courses and thus they become antecedent streams. Many of the Himalayan rivers are the examples of antecedent streams such as Indus, Satluj, Brahmaputra, Arun, etc. They were existing prior to the upliftment of the Himalayas. All these rivers flow in deep gorges. Superimposed drainage system. Like antecedent streams, superimposed streams are also not adjusted to regional geological structure and slope. Superimposed stream means the river which is flowing on a definite or particular geological formation and due to not get adjusted to the new geological changes that are taking place in an area. A superimposed drainage system is formed when the nature and the characteristics of the valleys and the flow direction of the consequent stream developed on the upper geological formation and the structure are superimposed on the lower geological formation developed on entirely different upper structure. Thus, the river maintains form of its valley, the flow direction and its drainage pattern as before. The drainage pattern which is evolved on the overlying rock is superimposed or imprinted on the underlying rocks. The drainage pattern which exhibits discordance with the underlying rock structures because it originally developed on the cover of rocks that has now disappeared owing to denudation. The rivers have been able to retain their courses notwithstanding the newly exposed structure. The direction of the former rivers followed on the earlier or overlying rocks continued to be the same despite the change in the geological structure. The river of English Lake District and Son River flowing over the Rewa Plateau are typical examples of superimposed drainage. One of the fundamental differences between superimposed and antecedent drainage system lies in the fact that the former represents the superimposition of the drainage pattern developed on the upper geological formation and the structure, or the overlying rocks on the lower structure, or underlying rocks which is different from the upper rock formation. Whereas antecedent river represents the maintenance of the former course of the river in spite of the upliftment of the area across the river. Drainage pattern means spatial arrangement or form of the drainage system in terms of geometrical shapes in the areas of different rock types, geological structure and climatic conditions. Drainage pattern is the networking of or the arrangement of the main river and its tributaries. The location, number and the flow direction of the streams or tributaries of a particular region depends on the lithological characteristics, tectonic factors and climatic condition. Since there are much variations in the environmental conditions of different regions, and hence there are also variations in the drainage pattern. Generally, the drainage pattern are divided into certain types such as trellis pattern, dendritic pattern, rectangular pattern, parallel pattern, centrifugal pattern or radial pattern, centripetal pattern, annular pattern, barbed pattern, pinnate pattern or herringbone drainage pattern. Now let us talk about the trellis pattern. Trellis pattern is a rectilinear pattern formed where the structural controls occur at right angles. In this type of drainage pattern, the river forms a net-like system and the tributary stream of each class flows roughly parallel to each other. The trellis drainage pattern develops in areas where hard and soft rocks occur roughly parallel bands. The consequent or the main river follows the direction of general slope, while the tributary stream follows the direction of the strike and meet the main stream at right angles. The trellis drainage system is well developed in the Appalachian regions of USA, where hard and soft rocks are found in alternate bands. Dendritic pattern. Dendritic or tree-like drainage pattern is the most common and widespread drainage pattern. The pattern is called as dendritic because the network of tributaries of the various orders along with the trunk or the master stream resembles branches of the trees. This type of drainage pattern develops as an entirely random network because of the absence of structural controls. Thus, a dendritic pattern will be characteristic of a terrain which is of uniform lithology and where jointing and faulting are insignificant. The streams in the drainage pattern follow the regional slope and therefore such streams are also called as sequent by Davis. In this pattern, the tributaries do not meet the main stream at right angles. This pattern is the distinctive feature of the regions having horizontally bedded sedimentary rocks or massive igneous rocks. The drainage basins of the river Mahanadi, the Godavari, the Krishna, the Kaveri in the peninsular India are some of the good examples. Rectangular pattern. Rectangular drainage pattern develops in a region where the rock joints form rectangular patterns. The network of the stream follows the lines of weakness like joints and fractures. The tributaries join master streams almost at right angles, and thus a rectangular drainage pattern is formed. This type of drainage pattern is developed in areas where structural controls imposed by the joints and fault patterns of the underlying rocks. Rectangular pattern shows some degree of similarities to trellis drainage pattern, as tributary streams in both the patterns join their master streams almost at right angles. In case of trellis pattern, the confluence angle is guided by strike and deep angles of the rock beds, while it is determined by lines of weaknesses like joints, faults and fracture. The second line of difference between these two drainage systems or patterns is related to the spacing of streams. That is, rectangular pattern is characterized by widely spaced tributaries, while the trellis pattern has a dense network of closely spaced tributaries. The typical examples of this type of drainage pattern may be found on the coast of Norway, Denmark and Scotland. Radial drainage pattern. Radial drainage pattern is also known as centrifugal pattern, formed by the streams which diverge from the central higher point like domes and volcanic cones, batholiths, residual hills, in all directions. The streams emerge as the central point and drain down the slopes in different directions. They are basically consequent streams since they follow the slopes. The entire drainage network of Sri Lanka exhibits the best examples of radial pattern of drainage. The upland situated in the southwest of Ranchi city has given birth to radial drainage pattern, wherein the South Koel, the Subarnarekha and the Karo rivers take the sources and radiate in different directions. The Central Plateau of France, the Laurentian Plateau of Canada, Amarkantak in India also have radial drainage pattern. Centripetal drainage pattern. Centripetal or inland drainage pattern is opposite to radial drainage pattern because it is characterized by the streams which converge at a point, which is generally a basin, a depression or a lake. The depression formed at the top of the Raigad dome in the lower Chambal basin has given birth to centripetal drainage. Annular drainage pattern. Annular pattern, also known as circular pattern, is formed when the tributaries of the master consequent streams are developed in a form of a circle. Such pattern is developed over the mature and dissected dome mountains, characterized by series of alternate bands of hard and soft rock beds, produces ringed belted structure. In this drainage pattern, the subsequent streams follow the curving courses prior to joining the consequent streams. The subsequent streams find it easier to erode concentric, less resistant rock strata. The mature dissected Sonapet dome of Uttarakhand presents an ideal example of annular drainage pattern. This type of drainage pattern exists in the Henry Mountains and Black Hills of USA. Barbed drainage pattern. Barbed drainage pattern is a rare kind of drainage pattern. It is formed when the tributaries flow in opposite direction to their master streams. The tributaries join the master stream in a hook-shaped bend. Such pattern is developed due to river capture. Parallel drainage pattern. Parallel drainage pattern comprises numerous rivers which are parallel to each other and follow the regional slope. The pattern is developed more frequently on the uniformly sloping and dipping rock beds such as 𝗓𝗏 or newly emerged coastal plains. The western coastal plains of India represents several examples of parallel drainage pattern, where the streams, after taking their sources from the western flanks of the Western Ghat, drain straight courses towards the west, empty into the Arabian Sea. The parallel drainage system consists of parallel master and tributary streams. Parallel faults, parallel topographic features are favorable to the development of this type of drainage pattern. The tributaries of Amazon, Mississippi and the rivers of Northwest Europe are some of the good examples of parallel drainage pattern. Pinnate drainage pattern. Pinnate drainage pattern develops in a narrow valley flanked by steep ranges. The tributaries originating from the steep sides of the parallel ridges join the longitudinal master consequence, occupying the valley at acute angles. The drainage network of the upper Son and Narmada river denotes the example of pinnate drainage pattern. Herringbone drainage pattern. Herringbone drainage pattern is also called as rib pattern, is developed in the mountainous areas where broad valleys are flanked by parallel ridges having steep hillside slopes. The longitudinal consequent stream as master streams are developed in the longitudinal parallel valleys, while the tributaries as lateral consequents after originating from the hill slopes of the bordering parallel ridges join the longitudinal consequence almost at right angles. The courses of the rivers are straightened because of the slope factor. Little distance between the ridges and the longitudinal consequence, occupying valleys, and thus the tributaries are not allowed to adopt sinus courses and join the consequence at acute angles. The upper Jhelum river in the Vale of Kashmir receives numerous tributaries from both the sides and thus forming herringbone drainage pattern. The rivers occupying east-west trenches in the Himalayas form herringbone drainage pattern. Drainage system is related to the origin, development of the river system, which is mostly controlled by the geological structure and slope of the area. There are two types of drainage system, consequent and inconsequent. Consequent drainage system is that which develops and is adjusted to the geological structure of the area. Inconsequent drainage is that in which there is no geological structural controls in the development of the drainage system. There are two types of inconsequent drainage system, antecedent and superimposed. Himalayan rivers like Brahmaputra, Satluj are the examples of antecedent river. Drainage pattern is related to the networking of the main river along with its tributaries. Based on the shape and geological condition, there are number of drainage patterns such as trellis, dendritic, rectangular, radial, etc.